Welcome to Classwork 9.2 Part 2. Today we're going to continue the study of the law of sine. So for now, take a moment to pause the video and just rewrite the law of sines above. Then once you're ready, unpause. So we're going to study three cases today. The information given is going to be a little bit different. And what we're going to focus on is this version of the law. Because you're going to notice in all the examples today, we're only going to have one angle given. So if I fill this in, A is 2, C is 1, and this right here is 50 degrees. Now the first step for law of sines is going to be always find the pair. So hopefully you remember that from our last lesson. And right now we can quickly see that the pair is right here. This is our 50 degrees and the 1. So that's going to be our key to solving it. So let's start there. Sine of 50 degrees over 1 should equal. And now notice the thing we have to find. We don't know anything about B, but we do know that A is 2, which means we can find this angle right here. So let's find that. That's going to be sine of A over 2. Okay, let's solve for A. So we're going to multiply both sides by 2. So sine of A should equal 2 sine 50. Now to get rid of a sine, right, because notice how we're trying to figure out what this A is, we have to use sine inverse. So simply sine inverse both sides like that. So A should be the sine inverse of 2 sine 50. So let's go to our calculator. So for sine inverse, what you have to do is hit shift sine. So there's your arc sine or A sine. Make sure your top right is in degrees. And we're going to plug it in. So arc sine or sine inverse of 2 sine 50. It says error. So what's happening is kind of what it says on the example. A few of you might have read this already. This actually has no solution. So pretty fast solve there. But unfortunately, we got to do a little more work than that. We got to figure out, like, why did that happen? So let's backtrack our work a little bit. If this happens to you, figure out what actually happened. Let's erase this, erase this. Let's figure out what actually is that 2 sine 50. So let's go back to our calculator. Let's just type in 2 sine 50. That's about 1.53. So we're going to write sine of A equals 1.53. That's going to be our first step. The second step is we got to realize that's actually an issue. Notice how sine of A is greater than 1. And we learned, think back to last chapter, the sine and cosine value can never be bigger than 1. So once you've established these two facts, sine is 1.53 and that's bigger than 1, you can write, therefore, there is no solution. Okay, so for no solution problems in your homework, make sure you follow these 3 steps. You establish what the sine value is, you state it's greater than 1, therefore there must be no solution. And those are pretty fast. Let's go to example 2. We're going to fill in our information. A is 3, the angle is 40, B is 2. So our pair, hopefully we're getting good at this, right here. So let's write it out. Sine of 40 over 3, that's equal to, notice how we're given B is 2, which means we got to figure out this angle right there. So sine of B all over 2. So let's multiply by 2. Sine of B must be 2 sine 40 over 3. And then we got to sine inverse this thing. So B should be the sine inverse of 2 sine 40 over 3. Now on your calculator, I'm going to show you this part because I want to make sure you guys can do it. Make sure you type it in exactly as it showed. So arc sine, put your fraction right there, and then 2 sine 40 over 3. And we're going to round to the nearest tenth for this. 25.4. So b equals 25.4. So for this, we're going to round to the nearest tenth. Okay, now unfortunately, we can't stop there. You're probably thinking, like, what else is there to do? We found the answer. And that's partially true. Let's think back to our last test. Imagine I told you sine of b is 1/2. On your calculator, if you did sine inverse, the calculator would tell you 30 degrees and 30 degrees only. And that's because the calculator is restricted, right? It only finds answers in quadrants 1 and 4. So what you need to do is manually find the other answer. So imagine I just told you to solve this thing. All of you would say 30 and 150. And that's because of the location on the circle. 30 is right here. 150 is straight across. And the link between these is quite simple. The link is actually just 180 minus 30. That's how you get this 150. So for this one, all you have to do is imagine this is like the thing we're given here. Just do 180 minus the thing you're given. So the second answer is going to be 154.6 degrees when you subtract it from 180. Okay, so there's our two possible answers. Now, a bunch of you may notice this. If this were 154.6, that creates a problem. That breaks the triangle, because a triangle can't have more than 180 degrees, which means that 154 conveniently doesn't even work. So you just cross that out, which means at this point, just like the problem says, there's only one solution, which is great. Let's fill it in. This is 25.4. And then the last angle, let's do a little bit of math here. That would be 114.6. And now we can find C. So let's go back to our pair. I'm going to flip it around now. So 3 over sine 40. You don't have to do this. I just flip it because it makes the work a little bit easier. Equals C over sine 114.6. Multiply by sine 114.6. So C must be 3 sine 114.6 all over sine 40. You plug in your calculator, you're going to get 4.24. And let's fill that in, 4.24. And I'll highlight that for everybody so we know what we found. So we found 4.24, 25.4, 114.6. And there we go. There's a complete answer. Now for the second one, this is going to be the most complex because already we know what's going to happen. This is going to be our two-solution problem. So let's start by just writing it in. A is going to be 6, B is going to be 8, this is going to be 35. And quickly we can already see here's our pair, right? So let's highlight that. Whoa. Let's put that right there. Okay, so there's our pair. That's great. And then it gave us B equals 8 right here, which means we're going to find this angle first. So let's write this out. Sine 35 over 6 should equal B, sine B over 8. Let's multiply both sides by 8. So sine B should equal 8 sine 35 over 6. We're going to sine inverse this thing, and then you're going to get B, that is 49.9. And then we're going to get 180 minus that, and that would be 130.1. So now we have two answers there. So what you're going to notice at this point is both of these actually work. So 49.9 works, and imagine you plug in 130.1. That still works too, which means I'm going to draw a second triangle. So I'm just going to draw a generic triangle right there. There's a second one. I'll label it the same way. A, B, C, A is 6, this is 35, B is 8, except I'm going to put 49.9 in this one, and 130.1 in this one. And now we just got to finish it twice. So not a big deal, it shouldn't take us too long. So let's focus on the first one. If we have 35 and 49.9, the last angle must be 95.1. Just add and subtract from 180, and then just work it out. C over sine of 95.1, that equals your pair, which is 6 over sine 35, multiply by sine 95.1. So C must be 6 sine 95.1 all over sine 35, which is 10.42. So 10.42. Okay, so I'm just going to highlight those answers we found. 10.42, 49.9, 95.1. Now go to the second one. Same thing. This last angle must have been 14.9 after you subtract from 180. So C over sine 14.9, that should equal your pair, which is 6 over sine 35, multiply by sine 14.9. So C will equal 6 sine 14.9 all over sine 35. So C must be 2.69. And there we have it. 2 complete triangles. Now, if you're wondering how this is possible, you can keep watching, but if you're not really interested, you can stop the video here. What I did on the bottom is I made a box writing how. I'm going to explain how this is even possible. Like, how could there be 2 triangles? What I did right here is I redrew the triangle we found first, that first triangle. So notice how the blue is everything given. And then the other part is what we found. What happened is this leg right here, this blue one, it's actually swinging in right here. And we're saying there's a second triangle possible with the exact same information, meaning this is still 6 right there. But what happens is the angles all change. Notice how B, instead of 49.9 on our other one, is 130.1, which makes sense because that is an obtuse angle. And then 95.1, notice how much smaller it got. It got 14.9. And finally, this last leg, this piece, instead of 10.42, it shrunk to 2.69. So all it's saying is that there are actually 2 triangles possible with the given information. And the whole idea is that this leg can actually swing in or swing out to create 2 separate triangles. So again, the 2 triangles, there's one like this, right there. That's going to be this triangle right there. And then there's the bigger one, like that. And then what happens is that this triangle kind of goes in. So if I were to grab this triangle, it kind of goes in like that. Okay, so that's the concept.